Hey math kids, we're going to finish up talking about trigonometric equations, and yeah, let's just get started. We have about 3 examples, but some of them have multiple parts. So, all right, we have square root of 3 sine x equals cosine x, and we're going to do that for 1 rotation. Okay, so what we're going to do is we're basically going to create a tangent function. So sine over cosine is tangent. So we divide both sides by cosine. So sine over cosine gives us tangent. So we have square root of 3 tangent equals 1. Then we divide by square root of 3, divide by square root of 3. And so that's what we end with. We have tangent x is equal to 1 over the square root of 3. Now we need to think of the point or the type of point that's going to give us that tangent value. And so we want square root of 3 on the bottom. So that's going to be our x value, is square root of 3 halves, and then 1/2 on the top, because tangent is y over x. So we want to find all the points that are in that form that give us a positive value. So if we're on the unit circle, the square root of 3 1/2 is our first, it's our pi/6 marking. Okay, and so we're going to get this point, but then also over here, because those are both positive, so that would give us a positive. And then over here, they're both negative, and so that will also give us a positive tangent, because negative divided by negative is positive. So these are 2 points, or 2 places that we're looking at. And then we simply just find those 2 angles. So we get pi/6. We also get pi plus pi/6. So that's 6 over 6. So that's 7 pi/6 and pi/6. So that's it on that one. Now we'll move on to this one. So it's square root of 2 cosine x minus 3 pi/4 plus 1 equals 0, and then we're going to go from 0 to 6 pi. So that's 3 rotations and a crazy equation. Okay, so we want to solve for the trig function first. So we're going to subtract 1. 2 O's. Cosine x minus 3 pi over 4 divide everything by root 2. We end up with cosine x minus 3 pi/4 equals negative 1 over root 2, which in the previous part of this video we realized is square root of 2 over 2. Okay, so I'm going to just ignore this. Now we draw our unit circle, and I guess before we do the unit circle we need to modify this. And so it's x minus 3 pi/4, and so it's going to be x minus 3 pi/4 right here. We have our less than or equal to signs. And then we need to do 6 pi minus 3 pi/4. So 6 pi minus 3 pi/4 times that by 4 over 4. Okay, so we have 24 minus 3, so that's going to be 21 pi fourths. And then 0 minus 3 pi fourths is just negative 3 pi fourths. Okay, so we need to figure out where 3 pi fourths is on here going backwards, because we need to know where we're starting. And so if we do that rough estimation, so we have 0 or 6, 1.5, 3, 4.5, this is going to be about 9 over 4, which is like almost 2, right? So it's going to be somewhere right here. But if we're going backwards, it's going to be somewhere around here, right? And so if we do, let's see, what's the best way to do this? If we just do 2 pi minus 3 pi fourths, we should get there. So we have 2 pi minus 3 pi fourths. And so we times that by 4 over 4. So we got 8 minus 3, so this is 5 pi fourths right here. Okay. Like rotating this direction. So this is 5 pi fourths. Okay. Now, when we're writing down our answer on this, we're going to start with, let's see, we have, right here, we have pi fourths, which gives us a positive square root of 2 over 2, but we don't really want that one. So now we're going to go over here, which is negative square root of 2 over 2, square root of 2 over 2. We have cosine, so we're interested in a negative x value. And then we also go down here, which is this same value. Okay. All right. So we're going to be here. We're going to be here because this is negative square root of 2, comma, negative square root of 2 over 2. Okay. So our starting point actually has one. That was our negative 3 pi fourths. Is right on there. Okay. Then we want to rotate until we get to 21 pi fourths. So we're going to just keep going. And if we go right here, this is going to be pi minus pi fourths. Which is 3 pi fourths. Okay. And so we get 3 pi fourths. Okay. And then we go to 5 pi fourths. And then from there, the last two, to get another rotation, we can just keep adding 2 pi fourths. Or, 2 pi. Which in this case, since it's got a 4, we're going to think of 2 pi, but we're going to multiply it by 4 over 4. So we're going to do 8 pi fourths. And so we're just going to be adding 8 to these until we get something that's too big for the 21. Okay? So if we add 8 to this, we get 11 pi fourths. If we add 8 to this, we get 13 pi fourths. Now we add 8 to that, and we get 19 pi fourths. And then if we add 9 to that, we get right on the 21 pi fourths. Okay, now keep in mind this was x minus 3 pi fourths. So to find our actual answers just for x, we have to do a little bit of algebra. And so we're just going to add 3 pi fourths to each of these answers. So that first one becomes 0. This one becomes 6 pi fourths. And I'll simplify these in a second. Then we add, and we get 8 pi fourths. We add 3, we get 14. We get 16. We get 22. And then we get 24. All right, now we got to simplify all these. So this is going to be 3 pi halves. 0 is still 0. This is 2 pi. This is 7 pi halves. This is 4 pi. This is 11 pi halves. And this is 12 pi halves. Okay, and that's what x is equal to. So this is still x as well. All right, hopefully you're still hanging in there. This is a little brutal. Okay, so now we're going to go from 0 to 2 pi. And it says give your answer in exact values. So we have 2 sine squared x plus sine x Okay, I'll just write this one on. We actually have this example has 2 parts, but I'll just do this one. Okay, so the first thing we have to notice, they're throwing a lot of stuff at us today. We want to factor out a sine x, and that leaves us with 2 sine x plus 1. Is equal to 0. And so if we solve these both individually, we're going to get sine x equals 0, and then 2 sine x plus 1 equals 0. And so that one's usable, but then we want to subtract 1. And then divide by 2. And so sine x, another thing we can use is negative 1/2. Okay, so we go to our unit circle. And we're interested when the y value is 0. So that's going to be here and here. And then we're also interested when the y value is negative 1/2. And so if we go to our first tick mark, the y value is positive 1/2. But if we mirror this down here, that's going to be square root of 3 halves negative 1/2. So that one works. And then if we go across here, that one will also give us a negative 1/2. Okay? And since we're going from 0 to 2 pi, it's only one rotation. And so just these 3 dots that I've marked in green, that's what we need to find the angle of. Okay, so this first one, since it's just going to be 0, right? So the rotation was just 0, and we rotate around till we get here, and that one's pi. Then we just rotate a little bit more, this because it is symmetric with that first one. It's going to be pi plus pi sixth. And so that's 6 pi sixth plus 1 pi sixth. So it's 7 pi sixth. Okay, and we rotate around to this point, which is going to be 2 pi minus pi 6. So that's going to be 12 pi 6th minus 1, so that's 11 pi 6th. And then we stop right here again, and because it's less than or equal to 2 pi, we're also going to include 2 pi. Okay, so that's our answer on that one. We're coming up to the last problem. I need more space, so let's go up here. All right, this time we have 2 cosine squared x plus cosine x minus 1 equals 0. And we're still just doing one rotation. Okay, this one we want to view like it's quadratic. And so we're thinking of this one like it's 2x squared plus x minus 1 is equal to 0. And so we want to factor it just with that in mind. So I'm going to do 2 times negative 1. I get negative 2. That's 1 and 2. And I want that to add up to a positive 1. So make that negative. I'm going to do my box right here. I get 2x squared. I get negative 1. I get negative x. And I get 2x. Okay, if I factor out, I get 2x. If I factor out, I get negative 1. Factor out, I get x. Factor out, I get 1. Okay, now we'll just test this. 2x times x is 2x. That works. 2x times 1, 2x. Negative 1 times x, negative 1 times 1. That all works. So I ended up with 2x minus 1 times by x plus 1. Now remember, our x's, though, were really cosines. So this is really 2 cosine negative 1, cosine x, negative 1, times cosine x plus 1, and it is equal to 0. This is all equal to 0. Okay, so we break those up. So we get 2 cosine x minus 1 equals 0, and we get cosine x plus 1 equals 0. So we add 1. Divide by 2. All right, so we got that. So cosine x is equal to 1/2. And also, this was 0. So cosine x is equal to negative 1. Okay, now we have those. Now we can go to the unit circle. So we draw a unit circle. Remember, cosine is an x value. So x value equal to negative 1 is only right there. That's the only place we do, or where that occurs. And then cosine of 1/2 is going to be our third tick mark. And so we can be symmetric and go down there. All right, so we just have 3 spots. We just need to find those values. Now, this one's kind of given because we're supposed to have this memorized. So that's going to be pi thirds. And these are going to be our x values. So x values as far as this is concerned. Now, this one we know is just pi. And then this one's going to be 2 pi minus pi thirds times this by 3/3. So that's going to be 6 pi minus pi, both over 3. So that's going to be 5 pi thirds. If you need additional help, come to Math Lab. Until then, calculator.